This
Teju, you can
conference
start.
will now be recorded.
Yeah, thank you. So we are using the database 2. Right click on the database 2 and click on new query. Okay, by default in the top, the database will get selected. So right click on database, new query. Okay, so this is the one. Yesterday we discussed about DDL commands. Yesterday we discussed about DDL commands, DML commands. So we discussed how to create the tables, alter the columns, add the columns, and how to change the data types, maybe increasing and decreasing the data types or changing the data types. And also we discussed what are the data types available in the SQL Server, right? Those things we discussed. Along with that, we are also discussed about the manipulated language, insert, update, and delete. Okay, these three commands. And post that we are discussed a few minutes about how to use the where class, right? So let's today discuss about couple of more options in the querying. One is group by, another one is having class, order by class. Okay, so these are the major parts. Whenever in the daily regular basis we will write on the queries and based on these options. Okay, so let's go back to querying. I have the employee table along with the department table. I have the employee table along with the department table. Now I want to know how many employees are there in each department. How many employees are there in the each department? How many employees in the 10 department? How many employees in the 20? How many employees in the 30? How many employees in the 40? Okay, just write on count of 1 comma DEPTNO. This is the column name. Whenever you use the aggregate functions are how many employees are there, that you can use the column name as well, EMPNO. Okay, along with that you can also use sum of salary. Okay, each department how much salary we are paying. Okay, so whenever you write this query, aggregates along with the other group by column, which is you are making a group, right? Each department as a group we are making. Out of that department how much we are paying, how many employees are there, what is the average salary, what is the total salary, what is the minimum salary, what is the maximum salary. All the functions we can use: minimum, maximum, average, sum, count. Okay, now if you run it, it will say one error. Okay, what is this error? It will say that department number is invalid in the select list. This column is invalid in the select list because it is not contained in either an aggregate function or in the group by class. Whenever you do select such kind of select, make sure that you are using a only aggregates. This is aggregate, this is aggregate, but this is not aggregate. Either you should keep this also in the aggregate or keep the group by class. Group by, keep the same column in the group by class. Okay, so this is the simple. So for the 10 department we are paying total 9,750 salary and also 4 members. For 4 members we are paying this much salary, right? So how many employees are there? 4 members in 10th department. How much total salary we are paying? 9750. Similarly 5 employees are there in 20. Similarly 6 employees are there in the 30. So whenever you want to make a group, okay, make sure that you are always using the group by along with the aggregates. Okay, whether you are making the group or not, whatever there in the select list, if you use the same thing in the group by list, it will make you distinct. It will result the distinct values of that particular column. So along with that, if you want aggregates, you can also keep it. Okay, if you are, how do you bring the distinct values in the result list? By using a group by. That is also one of the option. Okay, or we can also bring the distinct values by using a distinct keyword. This is another way to bring the. Okay, today you just read about which one is faster, whether I should use the distinct keyword to bring the unique values, or I should use the group by column to bring the unique data. So to bring the unique data, which one is better? See, both of them are resulting in the same thing, but which one is the better? Whether I should go with this option, whether I should go with this option. So you read about it, so you will come to know a lot of information by that. Okay, so this is the one thing we will use for making the aggregates. So whenever you want to make the aggregate based on one of the column, based on the group, so each class who is getting the maximum marks, each class which subject who is getting the minimum marks. So such kind of things are possible with the group by. Now I want to know out of this, in each department starting with the S name, the employee name starting with the S, how many such employees are there in the organization? Each department starting with the character S, how many employees are there? Each department, not overall. Okay, each department. Okay, so then we will go and keep where enaming like S percentage, starting S. Correct. So first I am filtering the data, the employee names who starts with the S. Post that I am making the group. See, if you want to filter the data, first you filter it. Where comes the first? Group by comes later. Where comes first? Always group by comes later. So first we are filtering. Post filter, whatever the data available, that data will get aggregated. If you see here, there are no employees under the 10 and 30. 10 and 30 department, there are no employees whose name starts with S. Smith. Okay, such kind of names are not there. Okay, now let's make one more percentage in the front. A, how many employees are there which their name contains a alphabet, either front, middle or last? So 10 department, one guy is there, 20th department, one guy is there, and 30th department, 5 members are there, whose name contains a character A. Okay, now I want to know with the character A in each department how many employees are there, but I want only the department which is having a minimum 2 employees. Minimum 2 employees with the character A in their names. Minimum 2 employees. So whenever you want to see, this is the employee count, right? Where minimum 2 employees. That means only 30th is having a minimum 2. Okay, these two are not having a alphabet A with more than 2, right? More than minimum 2 is not there, so it is only 1. So if you want to filter on top of the aggregate, okay, then you have to use the class called having count of employee more than or equal to 2 minimum. I want only the result with the minimum or count is more than 2, only this department. So employees whose name starts with A, and also we are making the sum and count of each department employees, and also we are filtering on top of the group. We are filtering again on top of the group. Whenever you want to filter on top of the groups, make sure that you are using the having class, not the where class. So that is the major difference. They will ask you what is the difference between the where and having. So having will filter post group, where will filter before group, having will filter post group. Okay, where class will filter before group by itself. Before making a aggregate, first it will filter the data, After filtering how many employees are there, that it will make the count. On top of that, I am filtering by using a having class. Okay, if suppose more than or equal to 1, that means everything will come, right? Everything will come. Now I want to order by class. Order by which one? First column, descending order. First column. I can also keep this, or I can say first column. Okay, descending order. That means that 30th department should come top, because aggregate is having a count 5. So if I ask descending, it will latest what is the value it is having, right? That will come in the top. It came first. So this is the way to write a query. Okay, first we will filter, post that we will make a groups, post that we will filter on top of the aggregate, and then we will make the order. This is the query order usually. Okay, if you are using all the classes in the query, this is the order. First you need to filter, post that, make the group, make that having class, and then order by class. Okay, all 4 of them has been applied here. Okay, right. Now, so let's make each department how many employees are there, right? We can also write one DPT number from employee group by DPT number. This will give you the how many employees are there in the each group, correct? Now I want to know what is this 10 belongs to. What is the name of the 10? Department number. Okay, department table. Let's go to the department table and check which department it is. Correct. What is 10? Accounting. Okay, in the account department, how many employees are there? 4. What is 30? 30 is sales. Sales department, we have 6 members, correct? So I want to know department name, employee count, or I want to know employee name, comma, department name. So these 2 tables are having a common column called a department number. If you go for these 2, okay, let's make it. Which one is common in between? Department number and department number, correct? So on top of the common column, we will make the joins, and then we will display the both of them in a single line. Whenever you want to fetch the data between common data between this one as well as this one, so what is the combination column we have to verify first? Whether the primary key is foreign key is present or not, that is not important. If common column is there, it can fetch the data. Okay, make sure that first you are identifying the right column, then we will go for the joins. Okay, now I will just explain. This is the first table, this is the second table. Okay, let's write the first table data here. Table 1, ID column, okay, 1, 2, 3, 4. Okay, so here table 2, ID column, we have 1, 3, 5. Okay, now table 2 is having a 1, table 1 is having a 1, 2, 3, 4, and table 2 is having a 1, 3, 5. Okay, what are the common elements and what are the common rows between them? This is the area, right? It will share both of them. Okay, so first one is 1 is common between them. Yes, table 1 and table 2, both of them are having a 1. Okay, number 2 is 3. 3 is having a both in the table 1 as well as table 2. So 2 is present in the 3 is present in the table 1 along with here also it is present. Table 2 also it is present. And what is the another element which is common? No other element. So what are the values available in the left extra? 5, only this one. And the right side which is having a extra 2, 4. This is called sets, right? Usually we will be what is this language? We will talk about sets, statistics, sets and relations, correct? So now this is the sets. So the table 2 is having a 3 rows and the table 1 is having a 4 rows. Table 2 is the first table, table 1 is the second table. Okay, so if you want to bring the common data between the two tables, okay, common data means only this. Between the two tables you want to bring only common data, then you write a inner join. So what is common between 1 and 3? So if you want to fetch the common data, that means matching data between the two tables, what is the join we have to use? Inner join. And then if you want to fetch only the matching data along with the left extra, matching data along with the left extra, we will go with the left outer join. We will go with the left outer join. Okay, so we will get 1 3 5. Okay, along with the matching data we will go for the right extra. We will call it as a right outer join. Okay, right outer join. So I want matching data along with the left extra and also right extra, full 3 of them, full outer join. Okay, I want only first extra. I want only first extra. I do not want matching data. I do not want matching data. I want only extra in the left side table. Okay, that is called anti-join. What is that? Anti-join. But SQL Server does not have the anti-join, but still MySQL has the anti-join and Oracle has the anti-join. But SQL Server has the option to bring that data, that we will discuss. Okay, so these are the joins: inner join, left outer, right outer, full outer, anti-join. Okay, these are the joins, but there are other joins. Okay, so those are all called, not that is only terminology, self join, okay, and cross join. Okay, those are self join and cross join, and those will bring the cross join. Means what are the number of rows in A into number of rows in B. In this scenario 3 into 4, because right side we have 1 2 3 4, left side we have 1 3 5, right? So 3 into 4. Okay, so we will get the 12 rows. Okay, that is called cross join. So there is no matching column will be there. It will just a Cartesian product, 1 into all the rows, 3 into all the rows, 4 5 into all the rows. Okay, that is called cross join. What is self join? Self join is just a terminology word which does not have the keyword. Okay, it is just a terminology word. It will use any of these joins inside. It will use any of these joins, but it is not a join. Okay, this is just a terminology between the same table. If you want to bring the data, then we will call it as a self, but there is no self in the real time. It is all of any of these joins we will use to bring the data in the single table between the two columns. That we will discuss it little later. Let's discuss about it. So in this scenario, let's go back and identify what are the two common columns between the tables. Okay, so first I will take first table as a department table. Okay, DEPT table. DEPT table is having a first column called department number 10, 20, 30, 40. Okay, 4 numbers are there. Let's keep it here 4. Okay, let's go to employee table. In the employee table, how many departments has been used? 10, 20, 30. There is no 40. 10, 20, 30. Only 3 departments are having a employees. But employee table is a foreign key, right? Multiple are there. So for the 10 department, we have multiple employees. So under the accounting, there are 4 employees working. Okay. So this is the second table. Okay. Total how many rows are there? 15. 15 rows are. Okay. Now what I want is, I want a department name, employee name, what is the salary he is receiving. Okay, employee, he is working in one of the department, right? He is working for the account department. What is the salary he is receiving? Okay, and which location he is working, location, and which location he is working. I want a report of this. Okay, so department name is present in which table? Department table. If you see here, department name is present in the first table, department name. Okay, department name is not there in the employee. You see, department name is not there. All other fields are there, but we have the option to bring the data by using a department number. Take this department number, go to the department table, okay, where 10, and then bring the accounting, and as well as the location is New York. Correct. So for that, right, we want to bring multiple columns, but few columns from this table and few columns from this table. Okay, so in this scenario, to bring the few columns from this table and few columns from this table into single row, see that single row we are keeping. Correct. So to bring that, we will use the joins. We'll use the joins. So I want to bring only the department names and also their employee names in the single row, only for matching, only for the matching. Whoever is having a department, I want only those records. I do not want extra information what is there in the left. I want only matching. That means that common elements between the two tables, right? So let's go with this. First table is select star from DEPT. This is the left table, and right table is EMP. Between the EMP, between this we will use inner join, just a keyword called inner join. Okay, so what is the common column between these two? Department number. On DEPT and DEPT dot department number equal to EMP dot department number. This is the common column. So this table is also first we have to identify the common column. This one is having, and what is the sharing of that column here? This one. So this is the common column. This is the matching column between the two. See, I am not talking about the name matching. I want to discuss about the only data. I do not want name, whether it is a matching or not. Don't, you no need to keep that, right? So in your mind, the data whatever is matching between the two tables, that is important. Here it can be a DID as well. The column name can be a DID. In the first table it can be a department number, and the second table it can be a DID. See, when I am creating a employee table, right? Create table EMP. Okay, employee ID integer, employee name varchar of 100. This is how we will create, right? Post that I will say DID integer references. Which table? DEPT table of which column? DEPT NO column. See, I am creating a employee table which is having a relation of the department number with the department table with the department number column. See, this foreign key table, which employee table shows the DID, whereas in the department table shows DEPT NO, but both of them are same. See, the name I am not giving properly. Okay, but when it comes to the matter, right, if it comes to the data, right, it is common data. So it is referring the same table, parent table. Okay, but name can be changed. But make sure that you are giving the same name so that maintenance will be easy. Easily we can identify. Oh, there also it is department. Here also it is department. But if you change the name, right, so we will confuse at later point of time. Whenever we will refer the relations, we will confuse. For that reason, we will make sure that both of them are having a column names also same. But it is not mandatory. That is up to you how you will create the table and how you will manage the relation. But it is not mandatory that same should be there in the both. So, but if you give that, it is good, and also it is better for maintenance. Future, if whenever we refer, right, we can easily refer. Now, because of this one, right, if you see here, oh, department number is there, and here also department number is there. That's why we are able to make it very easily and making the join. So if you change the column names, it is little difficult. You have to go through all the data. Oh, this might be the join column. Okay, or you just go to particular child table. If already primary keys and foreign keys maintained, sp underscore help table name is just pass and check the relational columns at bottom. This is the foreign key. So if you see here, this is the foreign key. What it is? References, department table, department number. What is the column name here also? Same. Okay, where we are finding this? sp underscore help table name. sp underscore help table name. So this will give what are the information it is providing? All the column names and their data types and their size, whatever we have provided. Okay, employee name, what is the data type we have given? Varchar, how much size we have given? 20. Okay, so when you created the salary, what is the data type you have given? Money, and money will take the 8. Okay, integer takes the 10 4 and money takes the 8, but only our duty is to check only for the varchar related. Okay, rest of them this is commonly it will provide. Along with that, it will also show what are the primary keys and what are the foreign keys in the bottom constraints. So it has one primary key, and which column? Employee number. Here it shows the primary key. See the constraint type primary key. Okay, and also here it is showing which column? Employee number. And foreign key to the department table, and what is the column name? Department. Okay. It will show us in the bottom of the sp underscore help. So it will give all that information along with the columns. It will also give the constraints. Okay, now we know. Now between the two tables, I want to bring the data. So I have used the inner join, and I know that this is the common column, and I'm putting on the common column. Now you display it. We are getting, see, first table having a 3 columns and second table having a rest of the columns. Okay, department Smith is working for which department? Research department. So earlier we do not have, right? So Smith is the 20 department. Go to the department and then check this department relay. Now I brought both of them into the single row. Brought both of them into single row. Now if you see here, department related columns came first because I put all the columns from both the tables. Now I will make the list of names, whatever the columns I want. Department table dot d name. I want only department name from department table, and employee name, employee table, I want e name, employee name. From the employee table, I want salary as well. I'm selecting the salary. From the employee table, I want suppose commission. I will also bring the commission. From the department table, I want DEPT, right? DEPT dot location. I want location as well from the department. So whatever the columns I need from both the tables, I have the provision to select all of them. I have a provision to select in the select part. Now you write location is not there. Go to the department. What is LOC? Not location. Okay. Now you go there. See, this guy is working under account department from New York. This guy is working a research department from Dallas. Okay, so this is how it shows the information in the join. See, and also here, is it showing department number also will display here. Okay, dept.deptno. So whether emp.deptno or dept.deptno, both shows the same thing. It is common column. But when you write a left outer join, there will be a small difference. Let's see that. Okay, now this is the department number. If I use instead of inner, what is the department table is the first one, right? What is the right side? Employee table. So if you want to bring the left data along with the matching, which join we will use? Along with the matching left extra. Okay, so what is the table we will use? What is the join we have to use? Left outer join, right? So along with the matching, we want to also bring left extra. So that is called a left outer join. Okay, go and make the left outer join. Remove the inner, left outer. So outer is a optional, you can put or you can eliminate. Okay, you no need to keep. Okay, outer is the optional keyword. So if you keep, it will work. Without also it will work. Now you see left side department number EMP. We kept the EMP, right? Let's make the DPT. See, for this one, right, we have, let's keep this location also in the first place, department number, location. All department related in the first and all employee columns in the next I kept. Okay, now you see we have the department 40 but does not have the employees. Okay, extra department 40 is extra, we are bringing that as well. Along with the matching information, we are also bringing the extra data from department table. Whether that department has the employees or not, we are still bringing it extra along with the matching left extra. So that left extra it will show. For that, even though 50 is there, so that will also come. But right side, whatever we are bringing from the right table, right, those are all columns show nulls here, because that is not having data for table, right? That does not have the data for that particular department. So that's the reason it will show null values in the right side. Okay, so are you following, right? So whenever you want to bring matching data, we are writing with the inner join. Whenever we want a matching data along with the left extra, then we will write a left outer join. Okay, now here whenever we go with the left outer join, what is the department number it will show in the employee table? Here I will write emp dot department number. Okay, emp dot department number. So but it will show null, right? Because it is not there in the employee table, the department is not there, so it will show null. What is the column? Common column, department number only. The department number 50 or 40, it is not present in the employee table. So if you want to bring only extra information, whatever is matching we do not want, I want only extra, that means only 5. Okay, in that scenario, what is the query we have to write? Anti-join. How do you write a anti-join? In the Spark SQL and MySQL, we have the anti like this, but SQL Server does not have that join. So how do we write the anti-join? Just put the left outer join and check the result, and in the right side whatever is showing, right, on the join column, whatever department is having a null value here. Okay, right, where class, where right table dot department number column, because that is the matching column. Okay, is null, is null. So it will bring only nulls now. See, this is the extra in the left table. We want to bring only extra. we do not want to bring matching data. So make sure that you are writing a condition on the right table, that too on top of the join column, on top of the join column only. Okay, so that's where it will bring the right data, which is having only extra in the left side. How do you bring the left extra, only extra information? He will ask you in the interview. So write a left outer join on top of the right table column name, make it A is null. That's it. It will bring only that data. Okay, so this is right extra. This is called anti-join. This is called anti-join, right? So now, if you want to bring the right extra, okay, think right extra. That means that there may be a one employee which does not have the department. I will make this guy's department number as a null. Okay, let's go and update. Update emp set dptno equal to null, where ename equal to 1 to 3. See, I want ename equal to 1 to 3. I am making a null for this guy. Okay, so one row got affected. Okay, perfect. Now if I go and I will remove this, if I go and write a right outer join, okay, right outer join, still I should get the, what are the extra records in the right side? Only this record, right, which does not have the department number, which does not have the department number. If I go and write here, see, I got the employee details, but the department information is null because the guy does not have the department. So left side shows that null. Now I will ask the one question. Okay, instead of writing a right outer join, why can't we shift the table to left side and this one table to swap the tables and use the left? Same, right? So ultimately, what, from which table you want to bring the extra? So from which table you want to bring the extra, put that in the left side. Correct, right? So left side and right, always left outer join, always left outer join. Along with the matching data, what is extra in the EMP? One record is there, which is 1, 2, 3. It will bring. See that it will bring. So you never write a right outer join in your life, because we are always using the, we know that initially, right, when we are analyzing, we know that the particular table matching data we should get along with the extra data. From which table? If you want to extra from the left table, DPT, put the DPT in the first. If you want to bring the EMP data extra, whatever is present, put that in the left. Which one extra you are looking for, that should be the first table. And always left is enough. Left is enough. Right is not required. Correct, because we know that which one requires the extra information we are planning to read, that we will keep it in the left side. So either change the join or swap the table, both of them will work. Okay, either you can change the join or swap the tables and use always left. Okay, so this is what, but algorithm wise, left is good, right join algorithm is bad. So you should never use this in the real time. Okay, always make sure that whatever you are looking for the extra information, that should be the first table, and use always left outer join. So algorithms, if you read right in left algorithm and a right algorithm is a bad algorithm, which as usually Microsoft is not supporting to use it in the real time. Okay, that's the reason I am asking. So use always extra information table, whatever you want to read, first keep the table and use always left outer join and read the full data, whatever you are looking for. But don't use the right outer join in that real time. Okay, so this is good. Now what are the joins we used? Left we used, right we used, and inner we used. And if you use the full outer join.
Sridhar?
So let me keep.
Srinath, sorry.
Yes.
In which situations we will use left outer join? Any example or live, like real time pro? Can you show any example?
Correct. Right now we saw that, right? I want extra. I want to see all the departments and their. The question here is, bring all the departments and their matching employee list. Bring all the departments and matching employee list. Then we will go for the left out, right? All the departments and matching employee list. If matching, it will come. If it is not matching, all the departments anyway is coming. Anyway, it is for me. See, left I kept. Bring all the departments and matching employees. I brought all the departments, including party and their matching employee information. Okay. So mostly 99% of the scenarios we will use left outer join. Inner join is very, yeah.
Can you tell
So
me about the equijoins?
come again.
Why?
Which one? Which one? Equijoin.
Yeah. In which situation and where we will use these equijoins?
Okay. Equijoin mostly if you say that suppose we have the products. Okay. Products are, okay. Suppose you think cycle India 10 sold. Okay. Cycle Pakistan 20 sold. Okay. Now let me go to the product table. This is sales table. Okay. Let me go to the product table. Products are cycle, car, and also we have Rexa. Okay, I don't know. So Rexa is there. Now car Pakistan 10 sold. Okay. Now you bring the products which are selling by our salespeople. Bring the products which are selling by our sales products. Okay. You think now which join is suitable here. Bring the products which are selling by our sales guys. Which are the products our sales guys is selling? Cycle and car. Okay, in our case, cycle and car, both of them are sold. In the sales table, 2 items are there, means both of them are sold, right? In the Pakistan, we sold car also. Okay. Now, which join we have to keep in this scenario? Think, okay. Sales table has 1, 1, 2. Okay. 1, 2, 3. This is the usual. This is primary key. Product ID is primary key in the product table and foreign key in the sales table. Correct. Foreign key in the sales table. Okay. Now, what are the products till now we are able to sell only cycle and car. How are you measuring that? We are keeping the what is the matching data between these two. Correct. Only matching. Okay. So if you want to bring what are the products till now we are sold. Okay. That time you go for the inner join. Okay. How many products we sold total? How many products we sold total? Car, how many cycles we sold? 30. 30, right? 30. Okay. How many cars we sold? 10. How many rickshaws we sold? 0. Then you bring that. You bring that in that query. We need to bring 0 as well, right? We need to bring 0 as well. How do you get the 0? First, you put a left outer join. Let's bring the first 3 into the list because we need all the tables, all the rows from here. So here, along with that, here we will say 30 in the report, right? So final report says cycle 30, car 10, and then rickshaw 0. This is the output I want. Which join you right now? Left outer join, because rickshaw does not have any entry here, but still we are looking for, right? So the management is looking for, then you go for the left outer join. That's it. This is the scenarios. We'll use the inner joins and outer join. Clear? Okay.
Srinath, can I use equijoint instead of inner join?
There is no equi, that is a terminology word. There is no equi join. It is a inner join. People will call it as a equi.
Okay.
So these are all the keywords. Apart from this, there are no other keywords available. Okay. That is whenever they write, right, they will say that equi join, but it is a inner join. Clear, right? So this is how we will see after a few days, right? You will learn everything. Okay. Now we are able to write. So now I want to get the employee. See here, employee 1 to 3 is not there in my list. Correct? Because we used the left outer join. We are getting the extra information from the department, but not getting the extra information from the employee. If we swap it, we will get it. But that time 40 will not come. Department 40 will not come. So, but I want extra along with the matching. Along with the matching, I want left extra and also right extra. And also right extra. That where we will go for the full outer join. Just put full outer join. Okay. Now if we see here, see 40 extra, we are getting a null values in that. It is 1 to 3 extra in the right table, and it is showing the left side nulls. Both it is getting. Along with the matching data, this is full matching data, left side extra plus right side extra. So if 10 rows are there in the right side extra, 10 will come. Left side extra, 4 rows, 2 rows are there, 2 will come. All the records extra from both left and right. That is called full outer join. How do you write a cross join? Okay, let's go to that. Okay, cross join. Select star, otherwise just star from DPT, cross apply EMP. How do you write a cross join? Cross apply. See this? How many rows there in this table? 4. In this 15. 15 into 4, 60. So cross join is nothing but a one row of this into all the rows, second row of this into all the rows, third row of this into all the rows, fourth row of this into all the rows. That means 4 into 15. We should get 60 records. Let's see the output. And see here, it shows the 60 in the bottom. Okay. If you scroll down, you see here 60 rows. Here you see the left side, right? 60 rows. You see the one of them each department. Okay. See the each department 15 are there, correct? Into all the employees. Again second 20 into all the employees. So that's how it works. First department into all the employees, second department into all the employees, third department into all the employees. Okay, now we clear. Now let me talk to little deep in the joins. Okay. Okay. We have the table 1. We have the data called 1, 1, 2, 3, 3. Okay. First table is having a 5 records. Okay. Now you should be able to tell me the output. Okay. Now second table is having a 1, 1, 1, and then we are having a 2, 2, and the third one we are having a 3, 3, and 3, and 3. Okay. Now you tell me. 1 second. Hold on. Hold on. I will put it side by side. Alright? It is not allowed. Okay, leave it. Now this is the data. You tell me now, for inner join, how many records I will get?
1, 1, 2, 2.
Okay, how many records I will get if I make a inner join between these two tables? How many matching records are there? Okay, I will keep 4 here.
3.
Okay, let me keep 4 here. Okay, let me keep 4 here, and also let me keep 5 here. So in this case, how to make it very clear? Let me not say. Okay, let me put this one also. Okay, now tell me what are the matching data? Inner join. How many records will get?
3.
Hmm?
3. 3.
1 it will match. First one, second one it will match. First one, third one also matches. First record is getting matched with the 3 records. That means 3. Okay, plus second one is matching with the 3 records. That means 3. And 2 is matching with the 2 twos. That means 2. First 2 will match with the first 2. 2 will match with the second 2. 2 records. Plus 3 is matching with the first 3, second 3, and third 3. Second 3 is also matching with the 3 T's. That means 6, right? 4 is not matching with anything. Okay, how many records we will get? Total 3 plus 6, 6 plus 6, 12 plus 14. If you keep the inner join, we will get 14 records. Okay. Now, so if I go with the left outer join, how many records we will get? 1 extra.
Only 1.
4 extra. 1 extra. That means that left join will give 15 records. Okay, right join will give how many records? No, 14 matching records plus right extra. That means 1 extra. 15 it will get. Full outer join will give how many records? Matching 14 plus 1 extra, right extra. So 16. Cross join will give how many records?
What?
So first table is having how many records? 6. 6. The second table is having 5. 5 plus 4, 9. 9 6 jar. How much?
54.
This many records will get. That is A into B, right? So that is Cartesian product. So 1 row into all the rows. So like that it will come. So 54 records will get. Clear? Yeah, someone is talking. Okay, just mute it if you are not asking question, please. Okay, now first row, what is the first one is matching with the 3 ones. You will get all the rows, right? So you just match it with the how many times that record is getting matched in the second table. Okay, now I will write one more thing. Okay, you just tell me the answer. Okay, 1 1 1 in the first table. Second table we are having a 1 1 1 1. Okay, now tell me the output of all the joins. Well, how many records we will get for the inner join?
12.
First one is matching with the 4 ones. Second one is matching with the 4 ones. Third one is matching with the 4 ones. How many records will get? 12. 4 3 12, right?
Yeah.
12. How many records will get for the left outer join?
12.
How many
15.
records will get with the right outer join? Is same. Right outer join also same. Full outer join also same. Cross join also same. Because all of them are matching with the same number.
Yes, yes.
Correct, right? So you should mindset, right? Just read matching. First to take one and then go with all. It is matching. You will get. Second one, take it, go with all. It is matching. Correct. Left also there is no extra. Now there is a one more small trick is there. So let's talk about that. Okay. Now I will give you one null, one, two in the first table. Okay. Second table, one, two, null, null, 3. Okay. What is the output for the inner join? What is the output for the inner join?
1.
9.
How many records? How many
9.
records? One is matching with the one. Again, second one is matching with the one. Two ones will come. Two is matching with the one. Two is matching with the two. That is also one record, right? So, how many records we are getting?
9.
So one we are matching with the two ones we'll get, and then 1 2 will get. 3 records. Nulls will never match. Null will never be a equal to. That's what I was telling from yesterday. Okay. Null is, if you want to bring nulls, right? Null will never equal to null. What should be the, how to check the null? Null is null. But inner join you are keeping equal to. You are not checking with the is. So null will never match. Okay, you have to remember that point. Never will never match in the inner join or left outer join, right? So extra as a extra it will come. But what is that? Okay, so never match. So one, two times one is there in the left side, one time is there. So for this one time is matching, one time it is matching. That is correct. One is two times, so two, and two is matching only once, it is three. But three does not have in the left side, right? So it won't match. Only 3 records will tell. But if you go for the left outer join, along with the 3, we have how many rows extra? 1 row null that will come. Equal to 4. One null is there. That will come. Okay. So if you go for the right outer join, how many records will come? 3 plus 2 nulls plus 2 nulls plus 3 extra, right? So that is 1. How many? 3 plus 2 plus 1, 6. Okay. How many will get with the full outer join? Matching data 3 plus left extra 1 plus right extra 3, 7. So whenever they ask the interview question, right, make sure that they will put the nulls compulsory in the list, and they will ask you to identify the records. Okay, make sure that you are ignoring that nulls in the inner join and include them in the left and right.
Srinath, can
Ignore
you explain one more time?
See, whenever you are having a null values in the left side or right side, it will never match with the inner join. Even though it has the null, but it will never come in the inner join. So null will never match with the equal to. Whenever you write a join, you write a join with the equal to here. Correct? Between the two calls. Say null is not, see, I will just explain you. Select null equal to null. Let me write like this. Okay. So null equal to null never match. Okay. If you want to make, this will match. Null is null. Yes, all the records will matching. So that's what I am telling. So whenever you do inner join you will do with the equal to. So in the equal to, the data will never match. Null data will never match. So what it will do, it ignores the nulls and it will identify the record match. So apart from nulls, only you make the matching data for inner join. Apart from nulls, that is the reason I kept 3, because one is matching with the one and this one is also matching with this one. 2 records we got and 2 is matching with this 2. One more record. So total 3 records we got in the inner join. Left join, along with the matching 3, we have one extra. What is that? We do not know. Leave it. Okay, extra anything is there, that will come. One extra is there, null value is there. So that's why we got the 4 records. And if I go for the right outer join, along with the matching data, 3 records, we will also have the 3 extra records, 3 1 extra and 2 nulls extra. So that's where it will bring 6 records. 7 records, sorry. Right outer join will give the 6 records, right? Correct. 6 records it will bring. Clear now? So in the interview, they will keep the nulls and they will ask you to identify the left, right and full. Okay. So you make sure that you are ignoring the nulls in the inner part. That's it. Rest of the part, let's make it.
Hello.
Okay. Yes.
Hello.
Hello.
Sir, in full outer join we don't match nulls, sir.
Full outer join, it will match nulls. That's why you see the 3 left matching data, 1 extra null in the left side and another 2 extra nulls in the right side along with the 3 extra. Total 3 records extra in the right side, 1 record extra in the left side. If you take example, right, this is extra and this is extra, correct? So along with the matching 3, we are getting these 3 record extra in the right side and this record is extra in the left side. Matching 3 plus left extra plus right extra. Total 7 records in the full outer join. Clear? Nulls will come in the full outer. That comes as comes as an extra. So these are the joins available. Okay.
Srinath?
Now, yes. Hello.
Can we get all matching data in single row?
All matching data in single row. What is the scenario? I didn't get it. Huh?
For example, there might be a accounting department.
Let me ask you. Okay. Let me ask you a question. Okay. Okay. You will new. Not so. One, two, three. Here, 1, 2, 4. Okay. Now you tell me what is the output you are expecting. How you want result? If you go for the inner join, it shows like this: 1, 1, 2, 2. Sorry, it will show like this. If you go for the left outer join, 3 null, it will show. Correct. If you go for the full outer join, null, 4 it will show. Correct. Till now we are good, right? Till now we are good. Okay. Now, apart from this, if only you are going for the inner join, how you want to see the data? How you want to see the data? Okay, how you want to see that? This is the inner join result. How you want this data? So it never be in a single row. Don't think that we have to show 1, 1, 2, 2 like this. That is called pivoting. Okay. So that never comes in the real time situation. You no need to worry. Okay. Let's identify the columns whatever required and just write it in the select part. Just identify whatever you want and write it in the select part. That is called join. Okay. Rest anything, right? That is comes in the different concept. Okay. Join talks about What is the matching data between the two tables? What are the data you are fetching from both the tables? I want only department number, department name, and also employee name and salary. That's it. I do not want anything else. So I will bring only that. It will show only in the table format. We cannot make it in the single row. This is inner join. Okay, think it is inner join. Okay. After getting this result, whether you want to make a sum of this or you want to make right, that you have made it. If you want data as a column, this goes into top. I do not want this. How I want the result is Sam working in the accounts department. His salary is 5,000. Here, hey, here sales department salary. Sam is also working in the sales department. He is earning 4,000 rupees. Similarly, here he will IT department he is earning 0. So these kind of things are a pivoting part. Okay, that never comes in this list. So when we talk about the pivoting, right, we will learn this, but this kind of situation will never come in the joins. Okay, joins will give as it is. The matching data are left outer, right outer, or full outer. So it will bring only the in the table format. So this is how we have to write. How to bring it? Just bring it whatever you want in the select list. That's it. There is no other part. And let me know how to practice this. Okay. Now in the SQL Server
Srinath,
also, yes.
one question. If I want to apply some in like employee sales, so if above, so where we need to apply some after the join or before, like select you before the from,
No.
where I
Post
can apply
joins
some.
only where will come. Post joins only where will come. The after that group by will
Okay,
come. After that having will come.
having.
After that,
Okay.
yeah. After that we will
So
get
that
R.
means in the where condition we can apply some, right? Or,
No, you cannot where condition, you cannot apply some. What is the requirement right now? Now
uh,
you think, step
sales
back,
salary, some salary, employee salary.
employee salary. Already there employee salary.
Yeah, some I need some.
Sum of what? On which column?
All
Sum
the
of on which?
all the all
All
the
the
employee
employees.
salary.
Okay. All the employee salary you want to show and show it as part of this employee. See, beside the Smith, right? You are
Or
showing the
department 20, all the employee salary.
okay, hold. Step back for a second. Okay,
Yeah.
let me. So let's understand. Okay, Smith is there. After the Smith salary is there. After that, you show something, some here, aggregated value, something here. There is no meaningless for that. That is not meaningless. Okay, if you show the total here, think. Okay, total. The column name is total, and you are showing that overall sum of this one you are showing here means there is no meaning. Beside the Smith, if you are showing the overall total, okay, how do you justify what this total is? Okay, think and step back one more second. And you want to Smith is belongs to 20. What is the sum of the salary you are showing? And you are showing the here sum of total employees under the 20, whoever is there, make the sum of their salary and show it here. In that case also it is meaningless, because beside the Smith you cannot show that overall total of all the employees of that particular department. Okay, that is also meaningless. Okay, make sure that the report is meaningful, right? Okay, there is an option. I am not saying no, I will come to that. Okay, how to show? I am aware of it. Okay, I will show that. Okay, now we will learn along with this. We will learn the analytical functions. analytical functions. Okay, I will coming to that. Yes, there is a possibility we will show sum of the salary or aggregated salary of that particular department as in the last column. Okay, that's where we will use the analytical columns, analytical functions. Okay, analytical functions are row underscore number, rank, dense rank, n-tile, aggregates with overclass, sum, max, min, avg. These are the aggregates. Count is also aggregate, right? So count. So how many analytical functions are there? Row number, rank, dense rank, n-tile, sum, max, min, and average, count. These are the analytical functions. Okay. Now let's go back to step back to here. Usually if you want to show the sum here based on the department number, then this is not the way to show this one. These two should not be there. Okay, here I will say sum of salary. Okay, sum of salary, I will remove this and I will make department number, this department number as a group, and I am showing it. You see here, D name. Okay, both of them, right? Yeah, let's keep it in the both of them. Okay, in the group by class. Apart from aggregate, whatever the columns available in the select list, make sure all of them is present in the group by. Okay, that is the thumb rule. See here, now 10 department name is this and their total salary is this. This is meaning, because this department overall wise, there are how many employees are there? For 3 employees, suppose think. Okay, here count of EMP and employees. How many employees are there? Group by see here, account department 3 members are there. For 3 members we are paying this much. This is the meaning, right? This is the meaning. Okay, but as you asked, along with the employee details, if you show this, right, if you show this here, we will get all the rows where you will, how do you distinguish, right? How do you cannot distinguish the data? So total means what total it is. If suppose this is a group total of department, then we can go with the analytical functions and we can make it. Let me show you that. Okay, okay, remove this. Okay, let's first we'll discuss about data first and then we'll go there. Okay, we'll understand the functions first and we will go later. We have the student table. One guy got 100 marks and another guy got 100 marks and another guy got 99 and then 98 got 3 members. Okay, 98 got 3 members. Okay, and then 97. Okay, think later whatever it will. Okay, now who got the first rank? Okay, think. Okay, this guy name is A, this guy name is B, this guy name is C, this guy name is D, my name is E, this guy name is F, and this guy name is G. Okay, now you tell me which guy got, which one, who got the first rank? A, B. Suppose this guy got the first rank and this guy is also got the first rank. Okay, how about 99? Which rank we should give him? Second. I will say 3. Universities will give 3 or 2. University
3.
will declare
3.
University guy will declare 3. Okay, let's go with the 3. Okay, think. Okay, maybe there may be a possibility either 2 is okay or 3 is okay. Okay, if you give 2 here, okay, what should be the next rank? Here 3. 3, 3, 3. Third rank got 3 members, right? If I give 3 here, suppose think, okay? If I give 3 here, third rank, okay? In that case, what will be the next rank? 4, 4, 4, 4. Okay, what will be the next? No, how come it is 5? It is 3 means next what will come? 1, 1, 2 is not there. 4, 5, 6, 7. Correct, right? 7. So university management is told very clearly, if any of them are got the same marks, next guy should get the immediate number. Next guy should get the immediate number. Do not skip the numbers. Okay. In that case, how do you get here? 2. Here 3, 3, 3, 4. Okay. Data is clear. Okay. Depends upon the university decision, you are supposed to generate a report. Correct. So management is declared. Okay. They may declare skip the number. If it you skip the number, it will becomes a 3 and this will becomes a 4 and this guy becomes a 7. If you skip the number, if you are not skipping the number, it will becomes 1, 1, 2, 3, 4. Correct. So let's write this. Okay. Create table, temp table I am creating. It will store in the temporary DB just for few minutes. Okay. Otherwise, once you close the window, it will expire. Okay. I am creating hash table. See here, I am creating hash table. Okay. Now name varchar of. See, I am giving ABCD, right? I will use the char of 1. Anyway, I am giving only one character. I can give char of 1. Fixed. Okay. And then here marks. Marks, what is the, we will give marks as a float. Correct. Maybe 44.3 marks also will come, right? So I'm giving a float. Here I will insert the score. Insert into hash temp values. First row I can also insert like this. Second row, third row, fourth row, fifth row, like this. Okay. So each row has the 2 values. Each row has the 2 values. Correct. This is easy. Okay. First guy name is A. His marks is 100. Second guy name is B. His marks is 100. Third guy name is C. His marks is 99. Fourth guy name is D. His marks is, and how much we are given? 98. 98, right? And then E. We given 98. F. We given 98. G. We given 97. Perfect. So all the rows I am inserting at one chart. Okay. This is the syntax. 7 rows got affected. Now I am writing a query. Let's go one by one. Okay. This is the record. First thing, hey man, I do not want 1, 2, 3 like this. I want always 1, 2, 3, 4, 5, 6, 7. So if you want to generate like this without any duplicate rank, okay, then row number will work in that scenario. Here you see row underscore number over order by marks, ascending order. Okay. Order by marks. Now you see that the syntax is row number over order by. Okay, this I will say as RNK. I will give rank. Okay, see 1 2 3 4 5 6 7. This is what we discussed. It is generating 1 2 3 4 5. It is not giving the same number even though duplicate is there. Correct. Row number will not generate any duplicate. 1 second. Okay, now this is done. I will go with the rank. What it will show you, see carefully. Okay, there is no repeated numbers here. Okay, I used the same syntax, no syntax change. Okay, same syntax. Rank I kept. Yeah, we are given ascending order. Let's give the descending order. Sorry, first two guys got 100, so they got the same rank. And then next guy 99. What is the rank it is given? It skipped. It skipped, right? And then 4 7. Rank will skip. If I go for the dense rank, 1 1 2, all 3s are 4. It is not skipping. Okay, that is the major difference between those three. So row number, rank, dense rank. Okay, based on the business ask. It is based on the business ask. You have to go one of these three. So business asked you to skip, you use the rank. Business asked to not to skip, use the dense rank. Business asked to display the sequence numbers based on the order, use the row number. That's it. Okay, clear? Okay, so now.
Yes, Srinivas, thank you. Srinivas, one thing. Can we see the table information for the temp table also, like SP underscore help? Is this possible for temporary table also? It's
No,
not possible.
temp table we never check that information because temp table will be stored only temporary. See, let me close this. Okay, if I close it, gone. Already it's gone. Okay, what is the point of checking? Anyway, you need to create. So there is no scope for checking it, right? It is not there already. Okay, so whenever you are there in the same window, your code is already there. If you are in the same window, definitely this won't go away, right? Control Z means it will come back. Even though you delete it, Control Z, you will get it. So once you close the window, whatever temp table got created, it will get expired. Here I have not executed, right? This is new window I pasted, right? So there won't be any data here. You see, it says very clearly invalid object because we closed that window, whatever we created. Again, you have to create. So the scope, I will talk about it little later. Temp tables, right?
Okay,
What is the scope and how to validate those things we will discuss about later. Okay. Okay. Temp table, you leave
thank
it.
you.
Just yeah. Here, our target is to understand the analytical functions. Okay. Let's understand it first, and then temp tables. Anyway, we will go through that later. And one more point here is select star from EMP. Okay. Let's go with this. Okay. Now, I will introduce the now. I will ask you the question and you have to answer it, which function it works for that. Okay. Now you know analytical functions very carefully, right? You know analytical functions, right? Now you tell me, overall wise, who is the third highest salaried employee in the employee table? Now, who is the third highest employed salary guy? Who is taking the third highest? You tell me who is taking the third highest. Let's go with the order by. Okay. Order by salary descending order. Okay, we can easily identify, right? Order by salary descending order. Let's go with that. Okay, now tell me, first guy is having a 5,000, second guy is having a 3,000, third guy is having a 3,000, fourth guy is having a this one, and fifth guy is this guy. Do you think this guy is the really fifth guy? If you take these two as a single guy, this is not fifth. Correct, this is not fifth. If you treat these two numbers as a different guys, then this is fifth. Correct. If it is 2 and 3, then it becomes a 4 and this becomes a 5. If it is a 2 2, this is 1 anyway. One record is there. Okay, this is not, this is similar, right? It will give, if I give the rank of 2 2, this becomes 3 in case of the dense rank. In case of the rank, it is becomes 4. And then it becomes a 4, this becomes a 5, you use the dense rank. If you use the rank, right? If you use, this will be 1 and this will be 2, this will be 4. It will be 4. It will be 5. If you use the dense rank, okay, 1, 2, 3, 4, this will be becomes a 5. There is a change. You have to ask them very clearly. Okay, how to treat. Okay, so based on that, you have to bring that. Now I will go and I will write a row number function. Row underscore number. You leave this order by. Okay, overall wise I am trying to bring number. Okay, over order by salary descending order as RID, row ID I am generating. I am using this and total 15 numbers will come because total 15 numbers are there. Because anyway it won't repeat the number, right? Row number will not repeat. So out of this, if I go for common table expression, there is a concept called common table expression with X as. Put the whole query in a bracket. Just immediately write select star from X. Whatever is there in the bracket, that will be treated as a X table, X. And then write overall query, it will display the same thing. From the X, it is so slow today. From the X, if I select this one, this is the fifth highest, right? So I will go and write a where RID equal to 5. If you want a fourth highest, give equal to 4. If you want a first highest, give equal to 1. Correct, right? This is easy, right? First generate the sequence of numbers, post that select whatever the rank you want. Got it? Now you got the fifth highest salary. If based on the business, if it is changing, if you want to use a rank, go with the rank. If you want to go with the dense rank, based on the business guy, whatever he proposes, right? Based on that, you know how to modify and other query, right? Now you know the differences between 3 of them. Use based on that. So based on the rank, if I go with, then 2450 will be the output. 2850. If I go for dense rank, I will get 2450. Correct? It differs, right? It differs. So based on the business ask, you first you identify, talk to them very clearly, and what are the expectation, because data is different. It is not distinct. It is duplicates are also there. In that scenario, how you want to treat. So based on that, we will change the analytical function. Clear? So this is the one thing. Now there is a one more small change is there in the query. Okay, one more small change is there. Let's learn that as well. If you go this, not this, employee, right? If I go over this, you don't think about the rank. Rest of them you think. I want each department wise who is the highest salaried employee. I want to fire them in the company. So company is getting the losses. I want to fire who is the highest salaried employee in each department. Each department separately, I want to remove them from the company. You just identify from each department who is the highest salaried employee. Now you tell me, who is the highest salaried employee from each department? Okay, let me write in the simple query so that we can remove this. Okay, remove this. Okay, order by department ascending order. Okay, let's go with the department number ascending order. Okay, all the employees of 10 will come first. Okay, all the employees 20 will come next. We can easily identify, right? Okay, now under the 10, who is the highest salaried employee? King. Correct. King is the highest salaried employee because he is collecting 5,000. Okay, If we go for the second, who is taking the highest salary? Both Ford as well as Scott. Correct. Scott and Ford are having a 3,000. These two guys. Okay. If you go for the 30, who is taking the highest salary? This guy. His name is Blake. If you want to display like that, right? Just ascending order, comma, salary, descending order. Okay. Then everything will come in the top. Now it is easy for you. Now you see here 10 first came, 20 3,000 first came, in 30 2850 first came. Order we are making on the department along with that salary descending order. So it's the first one. Now it is clear. Now we are able to identify, right? Let's make these guys number as a 1, and let's make this guy's number as a 1, and let's make this guy number as a this guy number as a 1. All the ones we will remove, and we will at least we will bring. Okay, so each department 1 2 3 it will display for this department. 1 2 3 based on this order. 1 2 3 4 5 1 2 3 4 5 6. Correct. Let's make the each department separate row numbers. For each department separate row numbers. Okay, let's go with that. Okay, I will remove this. I will say here based on the partition by department number. Just before order by, which column you want to make it as a group, that should be in the partition by column. Now I want a department as a group, each department separate sequence numbers. Department 10 1 2 3, department 20 1 2 3 4 5, department 30 1 2 3 4 5 6. Okay, let's see that whether we are expectedly coming at row number will generate first. Later we will discuss. Okay, first we will render the 1 2 3 4 5 6. See, where is that? 1 2 3, correct. 1 2 3 4 5, 1 2 3 4 5 6, correct. Each department we are writing. Now you tell me which row is having a highest salary from each department. All ones are having a highest salary because order by descending order, salary descending order. Take only ones, this one, this one, this one. These are the guys who are taking the highest salary from each department. Okay, now I will go and I will check where row ID equal to 1, because those people will come from each department. 1 is there, so these are the guys. Clear? So all the analytical functions will have the one more option called partition by. Partition by, that you have to remember. Okay, how to make split the table into multiple parts and generate separate sequence numbers for each group. If it is the class, partition by class. Okay, so each class who is the highest scored guy, that guy will get the first rank. Okay, then partition by class and order by score, descending order. Correct. So that's how we will generate the. If you want each department who is taking the third highest salary, 3, that's it. Correct. We are ignoring the 1 and 2. We are considering only 3. Okay, you want first highest salary and second highest salary, 1 comma 2. This we are already know, right? This we learned in class. First highest along with each department, second highest. Okay, so any doubts till now? Are you able to follow me?
Yes.
Okay, so this is the analytical functions. We will write tomorrow analytical functions with aggregates. What is the business case for that? We will just check that. Along with that, tomorrow we will go with the string functions, date functions, and what is that? Aggregate functions. Okay, so those 3 we will go tomorrow, and also we will write a little bit normal T-SQL queries. Okay, T-SQL means declaring a variables, all those. Okay, these are the majorly used asked questions in the interviews. So they will ask to bring each department who is highest salary, bring the third highest salary from overall table. These kind of questions they will ask, right? Make sure that you are utilizing the analytical functions. Okay, with the analytical functions it is very easy. Okay, tomorrow we'll solve the same problem with the old style, with the top keywords and the aggregates. That we will see tomorrow. Okay. Okay, you can
Srinath,
stop the recording. Yes.
uh,
Yes.
how can we get the who are not getting the salary null value? Like, can we get?
Yes. Select star from employee where salary is null.
Okay.
Where sal is null. I don't think we have. Yeah, there no one is there. Who is having a commission null? We will get. Commission is there. See, these are the folks who are having a commission null. Okay.
Clear.
So null, whenever you are comparing the null, just make is null instead of equal to. That's it. But null is always in the first preference in the order by. If you keep a ascending order, null comes in the first. Okay. So the rank, if you generate a rank based on the commission, right, all the nulls will get the first rank. Correct, because null will come in the first. So null does not have any value. 0 also after null only. Okay. Yeah. Okay. We will sync up tomorrow. Thank you.
Thank you.
Thank you all. Bye.
Yes, so much.